Hello, Mr. Eicher here. We're going to be looking at z-scores and percentiles today, two measures of position that we talk about. And z-scores are really important in AP statistics, so let's check it out. We're going to do four things: calculate and interpret a percentile, read a cumulative relative frequency graph known as an Ogive, calculate and interpret a z-score, and use z-scores to compare relative position. So here's a dot plot that shows the number of wins for the 30 Major League Baseball teams as of September 12th, 2020. The Padres have 29 wins. What percent of teams had 29 wins or fewer? To calculate that, we'd count how many teams, how many dots are 29 or fewer. There's 30, so 29 divided by 30 is 97%. So we'd say the Padres with 29 wins are at the 97th percentile, which to interpret that, we'd say 97% of teams have 29 wins or fewer. Part B, the Pirates have 14 wins. My hometown Pirates aren't doing very well. What percent of teams had 14 wins or fewer? Well, out of the 30 teams, there's only one team that had 14 or fewer, and that's the Pirates. So we would say 1 out of 30, 3%. 3% of teams have 14 wins or fewer. So a percentile is the value that has p% of the data less than or equal to it. And based on this definition, we can have a 100th percentile, but not a 0th percentile. Secondly, the type of graph that shows us percentiles is called an Ogive, or the longer name is a cumulative relative frequency graph. This is a cumulative relative frequency graph showing the distribution of median household incomes for each U.S. state and D.C. in 2019. The x-axis has median household income in thousands of dollars. The y-axis has the cumulative relative frequency, which is basically showing us percentiles. Part A, at what percentile is California with a median household income of $70,001? So to find that, on the x-axis, you would look for 70,000 and draw a line up to the graph, and then over, and that's your estimate of the percentile. So we'd say California is at about the 72nd percentile. California median household income is greater than or equal to about 72% of states. And that's how you'd interpret that. B, estimate the median household income. We have a median of the median household income. And the median is the 50th percentile. So on the y-axis, we'd look for 50% and estimate where that hits the graph. And that looks like about 62, 63-ish. So we'd say the median household income is about $63,000. So half of states have median incomes that are more than that, and half of states have median incomes that are less than that. Part C, what percent of states have a median household income more than $80,000? So on the x-axis, we'd find $80,000. And then that looks like about 90%, but be careful, it's more than $80,000. So we don't want to say 90% or 90th percentile, but it's actually 80,000 is at the 90th percentile, so 10% of states have median household incomes that are greater than 80,000. That's the second thing. The third part of class, we'll look at a new statistic that we haven't seen yet. This information is some baseball data, once again, same as before. And we have some summary statistics. N is the number of dots, the number of baseball team wins is 30. The mean is given as 22.1, and the standard deviation is given as 4.664. And then you have the 5-number summary. How far is the Padres' number of wins, 29, from the mean? Well, we do 29 minus 22.1, and that would be 6.9. wins. How many standard deviations away from the mean is this? Well, that would be 6.9 divided by 4.664, and that's about 1.5 standard deviations above the mean. So the Padres are doing really well. They're 1.5 standard deviations above the mean number of wins. We can do the same thing with my hometown Pirates with 14 wins. How far is 14 away from the mean? Well, notice it's going to be negative. 14 minus 22.1 is negative 8.1. So they're below the mean. How many standard deviations away is that? Well, we divide by 1 standard deviation, 4.664. We'd get negative 1.74. So the Pirates are 1.74 standard deviations below the mean. And that below is really important there, You don't want to say negative 1.74 below, because that's a double negative. But you should say 1.74 standard deviations below the mean is how you'd interpret that z-score. And that z-score, we basically took x minus the mean, x is the observation, 14 wins, minus the mean number of wins over the standard deviation number of wins. And that is also known as a standardized score, that z-score. And standardized scores, or z-scores, have magnitude, a value, and they have direction. And that direction could be positive or negative. But z-scores have no units. And you might be familiar with a certain character who mentions that he has both magnitude and direction, if you're familiar with the Incredibles. But the following situations decide whether you would want a positive z-score, a negative z-score, or no z-score, zero z-score. Salary at a company, you'd want a positive z-score. You'd probably want to make above average money. The daily commute, you might, well, it depends how close you want to be to your work, but you might want a negative z-score. That if everyone else averages 30 minutes to get to work, maybe you want to get there in 10. That'd be below average, a negative z-score. The time to complete the 40-yard dash, you would want a negative z-score. If you want to be below the average, if the average is 8 seconds and you want to be faster, you would actually need a negative z-score to be faster than average. Height, sometimes students will say, hey, I want to be a 0. I don't want to be too tall, I don't want to be too short, so I'll just take average. Some people say slightly positive z-score. I don't want to be like 10 standard deviations above the mean. I don't want to be a giant. But I wouldn't mind being a little taller than average, so a little positive. And then E, a golf score. Golf scores, you want low golf scores, so you'd want a negative z-score so that your value is less than the average. And then the last thing, we'll use z-scores to compare. If you'd like to pause the video and read, you can do that. But this says, the single-season home run record for Major League Baseball has been set just 3 times since Babe Ruth hit 60 home runs in 1927. Roger Maris hit 61 in 1961. Mark McGwire hit 70 in 1998, and Barry Bonds hit 73 in 2001. In an absolute sense, Barry Bonds had the best performance of the 4 players because he hit the most home runs in a single season. However, in a relative sense, this may not be true. Baseball historians suggest that hitting a home run has been easier in some eras than others. This is due to many factors, including quality of batters, quality of pitchers, hardness of the baseball, dimensions of ballparks, and possible use of performance-enhancing drugs. To make a fair comparison, we should see how these performances rate relative to other hitters during the same year. So in this table, we have the 4 given years, 1927 through 2001, the 4 baseball players, and how many home runs they hit in the given season. We also provide the mean number of home runs hit during that season, and the standard deviation of home runs hit during that season. So we can calculate the standardized score for each player and compare. Again, the standardized score is a z-score. So calculating the z-score for each player, I'd encourage you to pause the video and see if you can calculate those 4 z-scores. But we get these z-scores for Babe Ruth, 5.44, Roger Maris, 3.15, Mark McGwire, 3.88, and Barry Bonds, 3.91. So we'd say Babe Ruth's z-score, 5.44, is much higher than the others, so the number of home runs he hit relative to his peers is much more impressive than the other players. Part B, how many home runs would Barry Bonds in 2001 need to hit to have the same z-score as Babe Ruth did in 1927? So Babe Ruth had a z-score of 5.44, and using the z-score formula, we would plug that value in and get 5.44 equals x, the unknown number of home runs Barry Bonds needs to hit, minus 21.4 divided by 13.2. Solving that algebraically, we'd get x equals 93.2. So we'd answer the question, Bonds would need to hit 93 home runs to have a z-score like 5.44 that Ruth had. Thanks for watching this video. I'll see you next time.